Hello guys, next topic, rationalizing denominator. So normally we do not leave denominator with radicals. It is not a common form in mathematics. We do not leave denominators with radical. So we will rationalize it. We will make them be integer or any number but not radical. Okay, how to do? Let's see some example. For example, 8, this is on page 12. Okay, page 12. 8 over the third root, the cube of 54. So the first step, we simplify the radical in the denominator first. We simplify this one first. Okay, so what do you get here? 54 is 2 times 3 to the power of 3. 54 is 2 times 3 to the power of 3, and the index of this radical is 3. So we need to have 3 common number in order to take it out from the radical. So which number you can take it out? Here, 3 to the power of 3. So you can take it out of the radical here. Okay, after you simplify this term, you get this one. After simplification, you get this one. So begin rationalizing denominator. Okay, so here, how can we eliminate the denominator, which is the radical? We need to eliminate the radical in denominator, which is the cube of 2. So you have to multiply some number in order to fulfill the radical, in order to take it out from the radical. Can you follow me? Let's see here. The cube root of 2 mean to the power of 1 over 3, isn't it? So how many number in common in the radical to take it out of the cube root? 3. So we have two only one for 1. We have 2 for only 1. So we have to multiply 2 the power of 2 over 3 in order to make them be 2 the power of 3 over 3, and then we can eliminate the radicals, isn't it? And here, so we should add this number. Both numerator and denominator, but change this to be the radical form. So what do you get here? You get the cube root of 2 to the power of 2. Do you understand? The cube root of 2 to the power of 2. We need to have 3 common number to take it out from the radical, but actually now we have only how much? 1, 2. We have only 1. We need 2 more. So we will multiply 2 to the power of 2 here in order to fulfill the radical, okay? And then after you multiply, you get 8, the cube root of 2 to the power of 2. But the numerator, after you multiply this radical, what do you get? You get this one. Yeah? After you combine this radical, you get this one. The cube root of 2 to the power of t. The cube root of 2 to the power of 3 each 2. So 3 times 2 is 6 normally, but here you can see over there, when you multiply 8, you multiply this number with this one, you get this one, okay? And then you get this one. In the radical, 2 to the power of 2 can be 4, and here you can simplify 2 and 8, which is 4. So the final answer will be this one. Can you notice something? The denominator is not a radical anymore. The denominator is not the radical anymore, okay? try to multiply some number or some radical in order to fulfill the radical and take it out from the radical. That is the point. That is the point, okay? Let's see this one. 5 over square root 10, which means 10 to the power of 1, which means 10 to the power of 1 here. And the radical with no index, the radical with no index, commonly known as 2. So we need to have 10 for 2 terms in order to take it out from the radical. But now we have only one term, 10 for one term. So how to make them be 2? Which number you should multiply? You should multiply square root 10 both. You should multiply square root 10 both numerator and denominator. And what do you get? You get 5 to square root of 10 and 10 here. Square root 10 times square root 10 is 10, okay? And then you can simplify 1 over 2. So the final answer will be square root 10 over 2. The final answer will be square root 10 over 2. Okay. Next one here. Okay. The cube root. Cube root, what does it mean? We need to have 3 common number in order to take it out from the radical, isn't it? How many we have? We have 5x for how many terms? 2 terms. So how many times we need more? Only 1. So we multiply the cube root of 5x only 1 time. Already fulfilled. To both numerator and denominator. What do you get? You get this one. Isn't it? And down there, and down there, you see? What do you see here? You see? Can you notice something at the denominator? How many common number we need to have in order to take it out from the radical? 3. How many of 5x we already have? 3 as well. So we can take it out from the radical. So the final answer will be that is the way how can we simplify the radical, rationalizing the denominator. We normally do not leave the denominator with a radical, okay? Next one, more challenging here. More challenging question here. The question is this one. 5 over 5 plus square root 7. We normally know this method as conjugate. Conjugate, you have studied this in Mathayom 3, conjugate. Okay. 5 over 5 plus square root 7 here. How can we rationalize the denominator? Easily, you multiply itself but change the symbol from plus to minus, from minus to plus. Why? Can you remember this property? Can you remember this one? This will be a square minus b square, and the middle value will be eliminated. Okay. So multiply term by terms. You see, 25 minus 5 square root 7 plus 5 square root 7 minus 7 here. You see this one will be eliminated. And what do you get? 18. You see, the denominator is not a radical anymore. That's it. Multiply itself, multiply the denominator itself, but change the symbol from plus to minus, from minus to plus. Okay, that is a key. Okay, that's it. That's it. Okay, go to page 16 and let's do some exercise here. 19, 21, 23. 3 questions within 5 minutes. Oh, sorry. 25. One more. 25. Okay. 4 questions within like 6 minutes. Okay, I give you 6 minutes. Okay, let's see the answer. Okay, continue next video. Okay, let's see the answer in the next video. Okay, let's see the answer of 5 questions you have done. Here, rationalize the denominator. This one, which number you should multiply? You multiply the square root 2, both denominator and numerator. So you get 3 square root 2 over 2. That's it, the answer. 3 square root 2 over 2. Question 21. Firstly, you have to simplify the rational first. What do you get? To the power of 4. To the power of 4. Then take 2 out of the denominator. So you have you need to have 3. You need to have 3 common number before in order to take it out of the rational. Radical. So which number you should multiply? You should multiply the cube root of 2 to the power of 2. The cube root of 2 to the power of 2. So what do you get? You get 6. The cube root of 2 to the power of 2 over the cube root of 2 to the power of 3. Okay? And this one will be 6 the cube root of 2 to the power of 2 over 2, and then you can simplify, and the final answer will be 3 the cube root of 2 to the power of 2. Here is the answer of question 21. Okay, sorry. Can you add 2 here? And you add 2 here because I forget 2. Because we have 2 out there. 1, 2 out there. Here. Okay. Then over 2. That's it. Okay, I give you some time to take notes. Okay, question 23. Question 23. Question 23. You have to multiply the denominator itself but change from positive or plus to be minus. So you multiply 1 minus square root 5. So you get 2 minus 2 square root 5 over 1 minus 5, which is 2 minus 2 square root 5 negative 4. Okay, and you simplify to be 1 minus square root 5 divided by, okay, 2 here. Okay, last question ครับ question 25. So same as the question 23. Multiply itself denominator but change the symbol. Change the symbol from minus to be plus. So what do you get? 4. Seven minus 3. And then further simplify, you get 4 square root 7 plus 4 square root 3 over 4. And then simplify, eliminate 4. So you get square root 7 plus square root 3. That's it. in numerator and 4 in denominator cancel themselves. That's it. Okay, that is the end of this topic. Rationalizing denominator. See you next topic. Okay, last topic about the radicals. Combining radical expression. Remember, when you combine the radical, you can combine only when term like with the same index and same radicand. You can combine the radical in case of subtractions and addition only if the index and the radicand are same. Can you remember what is index and what is radicand? Okay, I will review for you. Here, index. Here, radicands. The index and radicand must be same in order to combining the radical expressions. Only in case of addition and subtractions. Multiplication and division is another story, okay? For example, this one, the question is square root 2 plus 2 square root 3 plus 4 square root 2 minus 4 square root 3. Can you see something? This one, same index and same radicand. You should combine these two. And here, same index and same radicand, which is 3. You can combine these two. So the answer will be here. 5 square root 2 minus 2 square root 3. You see this one? I will circle for you to see more easily. This one and this one. No number in front of the radical representing 1. So 1 plus 4 is 5. 5 square root 2. This one, 2 minus 4 is negative 2 square root 3. That's it. Okay. Let's see some example more difficult one. Okay. Let's see this one. Okay. Square root 50, square root 32, square root 2. So you have to simplify the radical first to see the pattern. What is the simplest form of square root 50? 50 come from 5 square times 2. 50 is 5 square times 2, okay? 32 is to the power of 5. And square root 2, we can't do anything further, okay? Square root 5 square times 2, you get 5 square root 2. Because no index, there is no index of the radical representing 2. Index is 2, always, okay? So we need 2 common number in order to take it out from the radical, okay? So we get 5 square root 2. To the power of 5, what does it mean? 2, there are 2 for how many terms? 5 terms. 2 for 2 terms, take it out from the radical. 2 for another 2 terms, take it out from the radical. Okay? So you get 2 times 2 square root 2, which is 4 square root 2 here. Yeah? Okay. And the last one, square root 2, cannot do anything further. So you can see, what you can see here, same radical and same index. So you can combine these 3 terms. So the final answer will be 2 square root 2. That's it. Okay, this example is same as the previous one, but you need how many? 3. You need 3. You need 3 in order to simplify the radical. Okay, but same as the previous one. So I will skip this part and try to do this one, which is more bit difficult. Okay, this one I will show you separately here. Square root 1 over 2 minus square root 1 over 8. So firstly, you have to simplify the radical. Square root 1 is 1. Square root 2 minus 1 over square root 8. So the first step, you have to do the previous topic we have done, rationalizing denominator. but okay, simplify first. This one is 2 square root 2. And what to do next? Multiply itself, denominator, in order to make denominator not to be the radical. Okay, what do you get? Square root 2 over 2 minus 2 square root 2 over 4. You see? Hey, sorry. Can you go back a little bit? I think we should do another method by simplify this one first. How can we simplify? Make the denominator equal. Make the denominator equal. The denominator is square root 2 and the denominator of another term is 2 square root 2. So we simplify this to be 2 square root 2. Multiply 2 to the first term and multiply 1 to the first term. Okay, take some note. Okay, then what do you get? You get 1 over 2 square root 2. Don't forget to rationalize the denominator by multiply root 2 on both. You get square root 2 over 4. That's it. I think this method is more easier than the one I did before. So I prefer this one, shorter and less complex. Okay, I give time for you to take some notes. Okay, continue. Let's see some exercise here. Okay, exercise here. Try to do question 27, 29, and 31. Okay, I give you like 7 to 8 minutes. Okay, let's see the answer of three questions. Okay, 27. The answer is simplify first. Okay, the first one will be 3 square root 3 minus square root 5 plus 4 square root 3 plus 6 square root 5. Okay, you see this one? Same index and same radicand. You can sum, you can combine. Same index and same radicand, you can combine. Oh, sorry, this one is square root 5, not 3. Same index and same radicands, you can combine. And then what do you get? You get 7 square root 3 plus 5 square root 5. That's it. Okay, 29. What do you get for the answer? Okay, simplify first. 75 is 5x 3x minus 3 square root 3x plus x square root x square square root 3x. Same index and same radicand, combine to be x squared plus 5x minus 3 square root 3x. Okay. Last one, 31. Square root 45. What do you get? Square root 45 is 3 square root 5 minus the sixth root of 125. The sixth root of 125 is the sixth root of 5 to the power of 3. So this will be 3 square root 5 minus 5 to the power of 3 over 6. Can you remember these properties? Yeah? The index will be denominator and the power will be the numerator, and then you further simplify. 5 to the power of 1 over 2. 5 to the power of 1 over 2 is square root 5. And again, same index and same radicand, you can sum, you can combine these two to be 2 to the square root 5. That's it. Okay, see you next video about the exercise of these topics. See. Okay, this video is about the exercise what we have done before, like 4 last chapters. Okay, we have done the odd number here, and we will do the even number, sum of even number. Okay, the first one tries to do question 2, question 4, question 6, 8, 10, 12, 14, 16. Okay, no question 10. No question 10. Just 2, 4, 6, 8, 12, 14, 16, and 20, and 24. That's it. I give you 10 minutes to finish these 10 questions, and I will show the answer each one. Let's do. Okay, let's see the answer together. Start with question 2. Question 2, okay. Firstly, the exponent is negative, so you take them down. And the answer will be 1 to 5. Okay. Simplify the expression. You will get negative 12, a the power of 2, and b the power of 1. Same base number and variable. In multiplication, you sum the exponents, okay? Next one. Okay, firstly, I think simplify in the bracket first. What do you get? 3, x negative 5, y the power of 5, and all of this multiply negative 2. You will get 3 the power of negative 2, x the power of 10, and y the power of negative 10. Negative exponent, bring them down. That's it. Question 6. And 3 the power of 2 is 9. Okay. Okay, take some notes. First 3 questions. Okay, question 8. Question 8. The fourth root, which means you need to have 4 common numbers or variable in order to take it out from the bracket. Take it out from the radical. So how much do we have? 3 to the power of 4 and 2 to the power of 4. So the final answer will be 3 over 4. Oh, sorry, not 3 over 4. 3 over 2. Okay. Question 12. Question 12. What do we have? We have the cube root of negative 64. We have the cube root of negative 4 to the power of 3, isn't it? Cube root means we need to have 3 common number in order to take it out from the radical. So we already have negative 4 for 3 times. So the final answer is negative 4. That's it. Question 14. Simplify the expression square root 48. Square root 48. How can we simplify? 48 is 12 times 4. 12 is 2 the power of 2 times 3 and 2 the power of 2, which is 4. So square root 48 is 2 the power of 4 and 3. You see, we need to have 2 common number in order to take it out from the bracket, and we have 2 for 4 times. Therefore, we can take 2 out of the radical for 2 times. So the answer will be 2 the power of 2 square root 3, which is 4 square root 3. Question 16. The cube root of 2 the power of 3 times 7. 2 the power of 3 is 8. 8 times 7 is 56. So we need to have 2 for 3 times. We need to have 3 common numbers in order to take it from the radical. And we have 2 here. 2 for 3 times. So this will be 2 the cube root of 7. That's it. Question 20. Question 20. Okay, the first step, rationalizing the denominator by multiply square root 18 both. So you get to square root 18 over 18 and then simplify to be square root 18 over 9, right? And then simplify square root 18 to be 3 square root 2 over 9 and eliminate this again. So the final answer will be square root 2 over 3. Last question. 3 over square root 5 plus 3 multiply square root 5 minus 3. Multiply itself as I told you, but change the symbol. So what do you get? 3 square root 5 minus 9 over, sorry, this one must be 5 minus 9, and then you get 3 square root 5 minus 9 over negative 4. Okay. And that is the end of today, and that is the end of the exponents and the radicals topic. Tomorrow, next time, we will continue next topic about polynomial. It will be something more, it will be something easier than this. I know this topic is a little bit tough for you, okay? See you.